Hello, I'm talking to you. This is Goddess of Science Physics, and I'm Mrs. Bolden, and today we're going to go over some practice problems using free body diagrams to find the net acceleration and the mass. When we went through the exemplars, there were 3 basic steps that you have to do to solve these problems. It's kind of like one builds on the next. The first thing is FNet. Find it. The second thing is to use FG equals MAG to find M. And then the third step is use FNet and mass with FNet equals mass times the acceleration net to get your acceleration. So all of these down through here should say net after them. It was an oversight of my fault. So if you want to make that change on your paper, that's completely fine. Okay, so let me straighten my paper a little bit here. All right, so first thing is FNet, find it. So we got a positive 20 newtons going down and 5 newtons going up. So that's going to be positive going down, negative going up. 20 minus 5 is 15 newtons down. Okay, so the first step, done. Next, we need to use FG equals MAG to find the mass. So FG, we know right here. So we know that 20 newtons is Fg equals the mass times the acceleration due to gravity, which we know is always 9.81. We're going to divide both sides by 9.81. And we get 2.039. So the mass equals 2.039 kilograms. The third step over here says that use the FNet, which we figured out, and the mass to find the acceleration. We can use kind of a fun little formula here. Rather than FMA, we can actually use A equals FNet divided by M. That way you'll get the acceleration directly. So A equals FNet, which is 15, divided by the mass, which we figured out was 2.039. So dividing those two numbers, you will get 7.36 meters per second squared. And because the net acceleration has to be in the same direction as the net force, it's also going to be down. Okay, so we found the net force. We used FMA with the acceleration due to gravity to find the mass. Then we used both of those to find the net acceleration. Okay, next one. So the next one we're gonna try to simplify as much as we can. So we know that the force of gravity, if we call that positive, the support force is going to be negative because they're equal but in opposite directions. They cancel each other out. So we know the net force is going to be 12 newtons to the right. Okay. So first part, not too bad. Then we're going to figure out what the mass is, and we're going to go force of gravity equals the mass times the acceleration due to gravity. And we know from looking at this, the force due to gravity is 9.81 equals the mass times the acceleration due to gravity, which should be like a little song in your head. Divide both sides by 9.81, so the mass is actually 1 kilogram. So the next one, we need to find FNet, and that's aNet, so it's going to be FNet divided by mass. We know that the FNet is 12 and the mass is 1, so the acceleration is 12 meters per second squared, and it has to be in the same direction as the net force, so that's going to be to the right. Okay. That one wasn't nearly as messy as the first one that we did. I'm getting better doing these. Okay, So now we have a couple of, we got to simplify as much as we can. We'll make force of gravity be positive and the force of air resistance be negative. Force of friction is 10 and the force applied is 10, so we're going to cancel those right out. We're not going to worry too much about them. So FNet is going to be Fg plus the force of air resistance, which is 38 plus a negative 19, which actually coincidentally is 19 newtons, and it's going to be in the downward direction. Okay, so now we're going to use Fg equals mag to find the mass. So Fg equals mass times the acceleration due to gravity. So Fg from down here, make sure I'm still, oh, I'm almost off the paper. I'm sorry about that. Fg is 38 equals the mass times the acceleration due to gravity, which we always know is 9.81. We're going to divide both sides by 9.81. And when we do that, we end up with a mass of 3.87 kilograms. Okay, so we're 2/3 of the way there. So now we just need to use our formula Fnet over mass equals the acceleration. So Fnet we figured out was 19 newtons divided by the mass, which is 3.87. Dividing those two numbers, we get 4.91 meters per second squared, and it's going to be in the same direction as the net force, which is down. Okay. Next to the last one, ooh, we're getting there. Look at that. We can see the bottom of the paper. So Fg is the only force that we have here. So Fg must be the net force, so it's 15 newtons down. And if the force of gravity is the only force, then the acceleration has to be 9.81 meters per second squared down. And then now we just need to use the Fg equals mass times the acceleration due to gravity. Fg in this problem is 15, so we're going to go 15 equals the mass, which is what we're looking for, times the acceleration due to gravity, 9.81. Divide both sides by 9.81. And you get the lovely number of 1.53 kilograms. There we go. Last one. Okay, let's end strong. So we'll call the force due to gravity positive and the support force negative. What do you know about these two? Since they're equal and opposite, then the net force is going to be 0 newtons. There is no net force. If there is no net force, there must be no net acceleration. So all we have to do is figure out the mass. And we know that the force of gravity equals the mass times the acceleration due to gravity. So we got 25 equals the mass times 9.81. We're going to divide both sides by 9.81. Do you sense a pattern yet? And so that means that the mass is going to be 2.55 kilograms. Okay, I'm going to flip the paper really fast to see if there are any on the back side. I don't think there are. Nope, there are not. Okay, so that's the last problem. Just wanted to review with you our steps that we commonly use. You find the net force first, then you find the mass using Fg equals mag, and then you're going to use both of those two, the Fnet and the mass, to get the acceleration using Fnet equals mass times the acceleration net, or you could use acceleration net equals Fnet divided by the mass. If this one is easier for you to use, great. If you can't remember that, you got the FMA formula, so you can manipulate that. All right, so that's it for this time. Have a nice day.